So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of preparing for the AQA GCSE Maths of 2022 Higher Paper 3 with a focus of the Geometry and Measure section. We'll be going over the advanced information and going over each of the topics in detail with what I recommend for you to revise before going through some past exam questions which should test your knowledge on all of those topics. Now the question sheet is available by clicking on the link in the description below if you want to have an attempt at these questions or while watching this video. Now before we get started working through some revision questions, let's just have a closer look at the comparisons between the Geometry and Measure sections on the Foundation Paper 3 and the Geometry and Measure on the Paper 3 on the Higher Paper. So as you can see, the ones highlighted in yellow are the ones that appear on both lists, and it kind of gives us an indication about what types of questions on the higher paper will seem quite easier, whereas the others may be in the middle to the end of the paper. Now you tend to find that the overlap between higher and foundation is that the last 8 questions on the foundation paper will usually be the first 8 questions on the higher paper. So looking at this, we can notice that compound shapes appear on both. So again, looking at area and volume, that could be related to area, it could be related to volume, and the fact that both cylinder is on both on the list. Now, the fact that cylinder is mentioned in the shape section for the foundation paper, but on the volume section of the higher, well, it could mean one or two things. It could be that the compound area is going to be just that, so involving rectangles, squares, potentially circles, but I think that that would have been mentioned on there. But again, for higher, it might be something that you're expected to know anyway, but I would say it could be trapeziums on there or any complex polygon on there as well. However, cylinders could be a separate shape. Now, however, or it could be the compound shape is a cylinder or involves a cylinder, in which the fact that no other shape is mentioned on the higher advanced information will probably imply that it could be a sphere. And the formula is going to be given to you of the sphere. So it could be a hemisphere. I'm not really too sure what that could be. But again, just notice that you need to know the formulas for each of those. The other topics are on there, trigonometry. Now again, trigonometry as a standalone is basically cosine sine rule. But the fact that it's mentioned on both could mean that you could get 2 questions on this. So one could be SOHCAHTOA trig and the other is going to be sine and cosine. And the other one is vector arithmetic. So again, you might expect this being the multiple choice question. So within the first 5 questions where you're expected to do a basic calculation with with column vectors. And again, there are plenty of examples that we go through near the end of this video. And then obviously we've got the standalone topics, which are quadrilaterals, circle theorems, cosine and sine rule, and bearings. So now let's have a closer look at the higher information regarding the geometry and measure on this paper. So looking into greater detail with what's mentioned on the geometry measure for this paper 3 higher paper, let's just go through the list. So compound shapes, again, a compound shape is just basically built up from smaller, more common shapes. And again, the fact that it's on the area and volume means that it's either going to be looking at area or it's going to be related to volume. So you need to make sure you're proper clued up on your formulas for areas of polygons and also your volume formulas for 3D shapes. Now the fact that it comes into cylinder, again, this could be linked with compound shapes, although I'm really struggling to see how it could be with it just being a cylinder. If there was, you could attach a cone or a sphere to it, but there's no mention of those 2 shapes. So again, I'll be very intrigued to see how it's linked in this question. So for a cylinder, you need to know the volume formula, which is just pi r squared times h. But also a question that I've seen a few times is where you need to construct the amount of a wired cylinder, and you may get asked to work out the total wire needed. So don't forget that the circles will be the circumference and the 2 sides, or the length of the rectangle, will be the circumference and the height of the cylinder. So again, you can then may get asked to show how much you're going to need for that. Again, it's very difficult to picture what that type of question could be, but again, could come up. The next one is quadrilateral. So again, for this, you need to be able to make sure that you know the properties of each of the quadrilaterals, and there are a few. So rhombus, trapezium, parallelogram, knowing what's regular, what internal angles, what their diagonals are like, and the relationships they have with each other. Circle theorems, again, is very broad in the fact that make sure you know what all the theorems are, but also know the correct definitions using words like subtended and all of those. Don't go for the describing a rule as that the bow or the arrowhead. You need to make sure you know the proper definitions to get those marks. For trigonometry, this again could be more likely to be SOHCAHTOA trig. So again, just make sure that you're not just applying the cosine rule or sine rule to every trig question you think, because that's the more complex topic. Right angle trig could easily come up both in part of a question or involved in the cosine sine rule, which is a nice little segue into that. So the next one with regards to sine and cosine rule, make sure that you know when to use each rule. So you use the cosine rule when you know three sides and an angle, and you use the cosine rule when you know 2 sides and 2 angles, where one of them is x. You also need to remember that the formulas are going to be given to you on the insert. And again, this topic could be linked with bearings, and there are so many questions linked with bearings with the cosine and sine rule and trig in general. So don't automatically think that the bearing question could be linked with cosine sine rule. It could involve the trig topic as well. With regards to vector arithmetic, that's just going to be simple column calculations. And as we mentioned, this topic does appear on the foundation paper, so I would say it's more likely to be a column vector calculation than it is to be based on a diagram, but you can't rule that diagram type question out. And then bearings, again, could be a standalone topic, although I believe that this would have been on the foundation paper as well. But I would strongly, if I had to put money on it, I would say it's going to be linked with the cosine sine rule or the trig question. So make sure that you know the 3 rules of bearing. So you always draw a north line, always go in a clockwise direction, and always give your bearings as a three-digit number. If a diagram's not drawn, which I would say is quite rare on an exam paper, make sure you draw one. And again, with lots of practice, you will master bearings with trig. And again, there are plenty of questions for you to attempt either online or in a textbook or in past exam questions. So let's get started on some of these revision questions. So looking at question 1, which refers to a compound area question, it says here is an L shape, all the dimensions are in centimeters, and the question is asking us to work out the L shape. Well, it says that the area of the L shape is 65 centimeters squared, and we need to work out the value of x. So looking at this, what we need to do whenever you end up with a compound shape is you want to work out what the missing sides are. So for this, what we need to do is work that out. Now, how we do that? Well, to work out this side here, well, if all of this is 9 and this bit here is 3x plus 1, then this length here is going to be 9 minus, and then it's really important we put brackets. We've got 3x plus 1. Now expanding the brackets, I'll get 9 minus 3x minus 1, and so that then becomes 8 minus 3x centimeters. And then to work out what this length here is going to be, well, that if all of this is 10 and this little bit here is x, then this length here is going to be 10 minus x centimeters. Let's just put them in brackets. So then once you've got the missing sides, what you then want to do is decide how are you going to split this L shape into 2 rectangles. Now what I'm going to go for is I'm going to split this L shape here. So the area of this, if we just call it A, is going to be x times the height, which is 8 minus 3x. And if I work out the area of this bottom rectangle, which we'll call B, that's going to be 10 lots of 3x plus 1. Now we know that the total area is 65 centimeters squared. So adding all them up, I get x and then 8 minus 3x plus 10 lots of 3x plus 1 all add up to 65. So then now if I expand the brackets out, I get 8x minus 3x squared plus 30x rather, plus 10 equals 65. And then if I neaten all of this up, I end up with 3x squared plus 38x plus 10 equals 65. Now you can see that slowly this is now looking like a quadratic equation. So when you think solving a quadratic equation, you need to think making it equal to 0. Now typically you might find yourself easier to take the 65 over to the other side, but instead what I'm going to do is I'm going to take all of the left hand side over to the other side, so I end up with a positive x squared, and what I end up with is 3x squared minus 38x minus plus 55, and again that would make that equal to 0, but instead of writing the 0 equals 0 on the left hand side, I'm going to write it on the right hand side. Now from this what we can then do is we now need to solve it. Now this does factorize as to 3x minus 5 and x minus 11 equals 0, or you could use the quadratic formula, so you can factorize or use the formula to solve, because all we wanted is to solve it, in which we end up with x equals 5 over 3 or 11. Now obviously x can only be one answer, so we've got to think which one is more likely to be the answer. So does this length here, if I just take this because this equals x, could that be 11? Well, no, it can't, because if all of this is 10, x can't equal 11, so it can't be this. So because x needs to be less than 10, so here then x must equal 5 over 3, or I could write it as a decimal, which is 1.67 to 2 decimal places. So any of those two answers would be absolutely fine. Moving on to question 2, another compound area question. So again, what we want to do is split this rectangle into this L shape into 2 separate rectangles. So I'm going to go for this here. Now if you did it the other way, so for example, if I split it like this, I'll end up with different working out, but the answer should be the same. So from this, well, this top rectangle is going to be 9 times 2, which is 18. And then working out what this length is, well, 8 take away 2 is 6, so that must be 6. Now note how there's no need for me to work out what this length here is. However, if I did split it, the L shape, into the other 2 rectangles, then I would need that yellow line. But for this I don't, so this is going to be 6 times 4, which is 24. So then the total area is going to be 18 plus 24, which gives me an answer of 42 centimetre squared. I think the units are given in this question. Yes, it is. So looking at question 3, it says that here are 2 rectangles. The area of the shaded rectangle is a quarter of the area of the large rectangle. Work out the value of x. So for this, what I need to do is work out what the respective areas for the 2 rectangles are going to be. So there's no information on the shaded rectangle. So this red line, well, if all of that is 12 and this little bit is x, so this red line must be 12 minus x. And if all of this is x plus 2 and this bit here is x, then this line here must be 2. So let me just stick that in a different color. So that must be 2. So then from this we can see that the area of the large rectangle is going to be 12 lots of x plus 2, and the area of the small rectangle is going to be 2 lots of 12 minus x. Now, so these are the 2 expressions that I'm going to be using. Now it does say that the area of the shaded rectangle is a quarter of the large rectangle. So if I take the small rectangle, which is 12 minus x, now that is equal to a quarter of the large rectangle. Now again, I would say that where a lot of students would go wrong with this, and I can see that I've already, no I haven't, so that's going to be 12, and that's then x plus 2, is getting the quarter on the wrong side. So if I just neaten up this left hand side, it's right hand side rather, and I just sort out this here, so a quarter of 12 is 3, so that's going to be 3x plus 2, and here I'm going to end up with 12 minus x. So then expanding the brackets, I get 24 minus 2x equals 3x plus 6. And then just solving this double-sided equation, so I end up with 5x equals, and it's going to be 18. So x equals 18 over 5, or 3.6 centimeters. And again, any of those two answers would be fine to get the full marks. Moving on to question 4, it says that a shape is made by joining a triangle ABC to a semicircle with diameter AC. And it says work out the total area of this shape. Now, as you can see, we've got two shapes here. We've got semicircle and we've got this triangle here. So looking at this, now I don't know the perpendicular height of the triangle, so let's just first work that out. Now for that, what I need to do is I need to use half AB sine C. So C is 124 and my A and B are going to be 8 and 10 respectively. So from this, what we've then got is a half times 8 times 10 times sine of 114. And if I type that all into my calculator, I get an answer of 36.5418 blah blah blah. I'm going to keep that just on the side for now, and that's the area of the triangle. Now to work out the area of the semicircle, I need to know what the diameter or the radius of the circle is, and at this stage I do not know what that is. I'm just going to call that x. Now hopefully what you need to know, or if I just look at the triangle as such, what I need to do is use the cosine rule to find x, which is the diameter of the circle. So to do that, using the cosine rule, let's relabel this triangle. So this now is going to be A, that's little a, that's B, and that's C. So that then becomes x squared equals, and it's going to be 8 squared plus 10 squared minus 2 times 8 times 10 times cos 114. So then typing that all into my calculator, again, x squared value of 229.07 blah blah blah, and so x equals, and that's going to be 15.135. so that's the diameter of the circle. So therefore then, to work out the area of the semicircle, so let's do that here. So the area of the semicircle is going to be pi times the radius squared, which is 15.135 divided by 2 squared. So that's the area of the full circle, and then I need to divide all of that by 2. And if I type that into my calculator, I get an answer of 89.9586664. And that there is the area of the semicircle. So now the total area is going to be 36.5418, whatever you've rounded that up to, plus 89.958, whatever you've rounded that up to, in which you should have an answer of roughly around 126.5. Now, if your answer is, now I've used the exact values, so if you find your answer is, let's say, like 126.54 or 126.48, then you still might get marks, because obviously there's around, you just need to look at the mark schemes to see whether you would get that final answer mark. But that there would be our final answer. I just need to write the units, and that is centimetre squared. Moving on to question 5. So again, continuing with the theme of the cosine and sine rule. And let's have a look at what I think looks like that. So the question says A, B, and C and ACD are triangles. The area of ACD is 80.5 centimeters squared. Work out the area of ABC, and we need to give our answers to 3 sig fig. So in order to work out the area of ABC, I need to know what the two sides are going to be. So for this, I don't know what that is. So let's have a go at working that out. So if I can then notice that this triangle ACD is a right angle triangle, so then this represents H. Now I know that the area of this triangle is 80.5, so that's going to be 80.5 equals 14 times H divided by 2. And if I manipulate that, I get H value, or 14H equals 161. So h equals 161 divided by 14, which gives me an answer of 11.5. So this length here is 11.5. Now from that, I can then work out what the area of the triangle in question of our triangle ABC is going to be. And how do I know that? Well, this here is going to be my angle C, this is going to be A, and that's going to be B. So the area using a half times A times B times sine C is going to be a half times 19 times 11.5 times sine 36, and I get an area of 64.2 centimeter squared, and that is to 3 significant figures. And again, that question's worth 4 marks, in which you get 1 mark for you writing your correct answer in the correct form. The next question then says Kate has the following question for her homework, and she's got a net of a box and with the dimensions mentioned. It says show that Kate can form the equation of this. So looking at the information that we've been given, we know that the area of this plus sign is 1000 centimeters squared. So what we need to do is we need to find an algebraic expression that represents the area of that and then make that equal to 1000. So looking at the big square, so if we look at the big square minus these little dashes, well, that's just going to be x times x plus 5. Well, actually, it's not a square, it's a rectangle. So excuse me for saying such things. So the area of the big square, well, I can't even call it a square, so let me get that. Call it a rectangle, is going to equal x times x plus 5. And let me just highlight that. So that's the area of the big square. Now each of these little squares are going to be 10 times 10, so that's going to be 100, that's going to be 100, and that's going to be 100, and that's going to be 100. So the area of the little plus sign is going to be equal to the area of the rectangle minus 4 lots of those squares, which 4 lots of 100 is 400. Now all of that equals 1000. So what I've got is I've got x plus 5 minus 400 equals 1000. So then from this, all I then need to do is expand the brackets and then make it equal to 0, in which then I should end up with what Kate has got. So 8 plus 5x minus 1400 equals 0, and there we've gone on to show this. The next question then says that Kate correctly factorizes the equation to get this, and it says her answer to the homework question is x equals minus 40 or x equals 35. Is she correct? Now, although she's factorized it correctly and she has got the 2 right solutions, that shouldn't be her correct answer. So the answer there is no, and the reason for that is because x cannot be negative. So the answer should just be 35, or x equals 35. And there we go. So because obviously if you look back, you can't have negative length here, so the x can't equal minus 40, because obviously then that would give you a space-time continuum. Moving on to question 7, it says that a rectangle of card 20 by 10 centimeters is used to make a cylindrical tube A as shown. The card does not overlap, and it says another rectangle of card 20 by 10 is used to make a cylindrical tube as shown, and the card does not overlap. And the question is asking us, the tubes are filled with clay, which tube uses more clay? So in other words, the question is asking which cylinder has got a greater volume. So for this, what we need to do is work out the volume of each of these shapes. Now again, to work out the volume of a cylinder, it's pi r squared times h. Now here, this length here is the same as this. So if that there is the circumference, so C equals 20, then the diameter is going to be 20 divided by pi, which therefore means that the radius is going to be 20 divided by 2 pi. Now, again, you don't need to write that. You could write it in terms of the numbers that you should get. So 20 divided by pi is 6.366. And if I divide that by 2, I get an answer of 3.18 to 2 decimal places. So that there is the radius of this. So therefore, the volume of tube A is going to be pi times 3.18 squared times h. Now, if you've left your answer for the 3.18 on your calculator, you can just square that, then times it by pi, and then times it by h, and you probably end up with an exact value of trig, exact value in terms of pi. So let me just quickly work that out. So 3.8 squared times pi times 20, and let me just write that down. Pi times 3.18 squared times 10, in which I get an answer for the volume as 317.69, and that's in centimeter cubed. So then working out the volume of this, so again, the circumference of this cylinder is going to be 10, so C equals 10. So the diameter is going to be 10 divided by pi, so the radius then is going to be 10 over 2 pi. But again, working that out, 10 divided by pi, if you wanted to work with decimals, is 3.18, and then dividing that by 2, we get 1.59. So then from this, what we then get is the volume equals pi times 1.59 squared, this times 20. And if I type that all into my calculator, I get an answer of 158.8. So which one has got a greater volume? Our answer is going to be tube A. And again, if you want to show, I would say if you've got time at the end, you could say like 317.7 is greater than 158.8, or you could just say that therefore tube A's got a greater volume. Moving on to question 8. So this involves cylinders. It says that this building block is in the shape of a cuboid. The block contains one steel cylindrical rod of length 90 centimeters with a radius of 4 centimeters. Rest of the block is concrete. Work out the volume of the concrete in the block. So the volume of the concrete is going to be equal to the volume of the cuboid minus the volume of the cylinder. So these are the two things that we then need to work out. So the volume of the cuboid is going to be where I multiply all the lengths together. So that's going to be 20 times 15 times 90. Again, type that into my calculator. 20 times 15 times 90 gives me 27,000. And so then the next thing I then need to do is work out the volume of the cylinder. So the volume of a cylinder, remember, is pi times r squared times h. So the radius, it says, is going to be 4. So that's just volume of the cylinder is going to be pi times 4 squared times the length, which is 90. And typing that into my calculator, I get 1440 pi. I'm going to leave my answer in terms of pi just because I've not finished the question. So in the volume of the concrete, let's actually do that in a different color. So the volume of the concrete is going to equal 27,000 minus 1440 pi. Now, if you've written that as a decimal, absolutely not a problem. I've just kept it in terms of pi because I know I haven't finished, and it's a lot easier to me to write 1440 pi than it is to enter a long decimal answer, in which I should get a final answer of 22,476.1, and that's going to be in centimeter cubed. There is my final answer. Moving on to question 9, again, a question that generally comes up a lot, is the shorter side of a parallelogram has length of 6.5, and it says the length of the shorter side is 1/9 of the perimeter. Work out the length of the longer side. Now, there's a couple of ways in which you could do this particular question. As long as you're getting the right answer and you're showing some working out, it should be fine. So I'm not going to go through all the methods, but I'm just going to go through the one that comes to mind first. So first of all, I'm going to start by calling this the missing sides as x. Now the perimeter is 1/9 of the shorter side, so therefore that the perimeter must be 9 times 6.5. So if I do 9 times 6.5, it gives me an answer of 58.5 centimeters. So that's what the perimeter is. Now algebraically, the perimeter equals 2 lots of x plus 2 lots of 6.5. So p equals 2x plus 13. So if the perimeter equals these two things, then I can then make them equal to each other. So here I've got 2x plus 13 equals 58.5. If I take the 13 over to the other side, I end up with 2x equals 58.5, take away 13, which is 45.5. So therefore x equals 22.75. And that's what one of the longer sides equal, and that's in centimeters. Moving on to question 10, it says that the diagram shows a wall. The area of the wall is 39.2. Work out the length of the wall. So for this, we recognize that the shape is a trapezium. And the area of a trapezium is a plus b times h divided by 2, or half h ab. So this is my b, this is my a, and this is my h. And in the question it says that the area is equal to 39.2. So what I get, substituting numbers in, I get 2.1 plus 2.8 times h divided by 2, and that equals 39.2. Then all I then need to do is simplify and go on to solve. So simplifying the bracket, I get 4.9 h divided by 2 equals 39.2. Take the 2 over, so 4.9 h equals 78.4, and then divide, so h equals 16, and that's in centimeters. Moving on to question 11, it says here is a sketch of a quadrilateral. So this is where you're just checking the properties of a quadrilateral. It says all lengths are in centimeters. Now tick one box for each statement. So here the quadrilateral is a rectangle. Now again, this might be true because the opposite sides are equal, but however we don't know what the internal angles are, and in order for it to be a rectangle they all need to be 90 degrees, so it may be true. The quadrilateral is a parallelogram. Well, that is going to be true because this angle is going to be the same as this angle here, and that angle there is going to be, oh, let's not definitely not put a square there, and this angle here is going to be the same as that angle there, so that is going to be true. And then is it a rhombus? Again, that's not going to be true because you need two sides, all sides need to be the same. And is it a kite? Again, not true because the two sides of the adjacent sides of a kite need to be the same. Moving on to question 12, it says ABCD is a quadrilateral. Prove that ABCD is not a cyclic quadrilateral. Now, if ABCD was a cyclic quad, then opposite angles equal 180. Now, whenever you got proved questions, it's always important that you do state what rule you are assuming to be true, and I would always start with that statement. So if I can prove that this is true, then it is going to be a cyclic quadrilateral. So I need to disprove because it's asking me not to prove that it's not. Now, what I need for this is to basically know some facts. Now, I know for a fact that whether a quadrilateral is in a circle or not, all the angles need to add up to 360. So for this, what we need to do is first of all find x. So we know that 4x plus x plus, and that is a 36 if I'm not mistaken, yes it is, plus 92 plus 5x plus 30 must all add up to 360. Now if I neaten all of that up, I end up with 10x plus 158 equals 360. Then go on to solve that, so 10x equals 202, so x equals 20.2, and that there is a fact. So from this, what we can then show is, let me just get rid of that little line there, just create a bit more space. So then if we look at angle A, that's probably the most easiest one to look at. So BAD equals 4x, which equals 4 times 20.2, which equals 80.8 degrees. Then if we look at the angle that's opposite that, which is 92, so DCB is equal to 92. So as 80.8 plus 92 does not equal 180 degrees. ABCD is not a cyclic quadrilateral. With one L, don't know why, 2. Not a problem. And there we go. Moving on to question 13. So this is looking at circle theorems. It says that A and B are points on a circle. PA and PB are tangents. Work out the size of APB. So we're asked to work out what this angle here is. So let me just label that as X. Now because they're both tangents, I know that those two lengths there are going to be the same size, which therefore makes this triangle of ABP an isosceles triangle. So this angle here is going to be 71. So to work out x, I do 180 minus 71 minus 71, which gives me an answer of 38 degrees. Moving on to question 14. So again, we're looking at circle theorems. It says that C, D, E are points on a circle. Is x in the center of the circle? So let's have a look first. So what we want to do is want to work out what this angle here is. Now that angle is around a point, so it's 360 minus 204, and that gives me an answer of 156. Now if point X is at the center, then this blue angle needs to be double the size of this angle here, because obviously that there is one of the circle theorems. So 78 times 2 does equal 156, so the answer is yes, and then it's just a case just writing that. So if at the center the angle subtended at the center should be twice the size of the angle at the circumference. Scroll down a little bit. So as 78 times 2 equals 156 degrees, x is at the center. Now you probably didn't need to write that much working out, but again I'm just trying to make my point a bit obvious. Moving on to question 15, it says that A, B, C, D and E are points on a circle. B, F, D and AFC are straight lines. DC equals DF. Work out the size of angle X. You must show your working, which may be on the diagram, which is a really good thing to note. So let's have a look at what we know. So from this, I can see that this is an opposite angle. So this angle here is also going to be 3x. That red angle is 3x. Now I can also see a bow, so this angle here is going to be the same as this angle here, and I can also see that this triangle is an isosceles triangle. So then to work out what this angle here is going to be, That's going to be 180 minus 24 divided by 2, which gives me an answer of 78 degrees, which means that this here is going to be 78, which also means that this angle here is going to be 78. So then to work out x, if I take all of this, let me just put a massive circle around it, then all of those angles added up need to equal 360. So what I've got is I've got 3x plus 3x, which is 6x, plus 2 lots of 178, which is 156. And that should equal 360. So then going on to solve this equation, I get 6x equals 204. So x then equals 34 degrees. And there is my final answer. Moving on to question 16, it says A, B and C are points on a circle. PAQ is a tangent to the circle, and it says work out the size of angle CAB. So let's just first of all note what angle we're trying to work out. So this is the angle in question, so let's start by calling that x. So from this we know that this angle here is also going to be 74 degrees, and the reason for that is because of the alternate segment theorem. And then angles inside a triangle, so then we do 35 plus 74 plus x equals 180. So x is going to equal 109. Oh no, x plus 109 equals 180, and so x equals 71 degrees. Moving on to question 17, it says E, F and G are points on a circle with centre O. Work out the size of angle W. Well, again, looking at circle theorems, this angle here is going to be 100. It's an arrowhead. And this triangle EOG is a isosceles triangle because they're both those two sides are the radius. So then to work out W, it's going to be 2W plus 100 equals 180, and so 2W equals 80, so W equals 40 degrees. Moving on to question B, it says A, B, C and D are points on the circumference of the circle. Work out the size of angle X. So again, it's a cyclic quadrilateral, so opposite angles need to add up to 180, so that therefore is going to be 112 degrees, and the reason for that is because opposite angles in a cyclic quadrilateral add up to 180 degrees. And then looking at question C, again apologies about the formatting of this, it says PTQ is a tangent to the circle, RST are points on the circle, and the question is asking us to work out the size of angle Y. So looking at this, it's going to be an alternate segment theorem, so angle Y is going to be the same as this angle here, so it's going to be 37 degrees, and the reason for that is because of the alternate segment theorem. And thankfully we've moved away from circle theorem questions. So moving on to question 18, which again looks at trig and using the sine rule. So for this, it says here is a triangle, circle the correct equation, and it's just going from here. So again, the labeling of this has not been labeled, so you just need to work that out, but the correct answer you should have is this top right hand one. Looking at question 19, it says Liz and Tia are walking towards a shop along different straight paths. The diagram shows the position at 2 p.m. Assume they walk at the same speed. Who will arrive at the shop first? So what we need to do is we need to work out what this length here is. So if I just start by calling that x. So here I've got three sides and an angle, so I'm going to be using the cosine rule. So for this, we've got x squared equals 80 squared plus 60 squared minus 2 lots of 60 times 80 times cos 75. And if I type that all into my calculator, get x squared value of 7515.337167, and I'm just make that point there. And so x equals 86.69 miles or meters. I'm guessing it's miles. So that's how far t has travelled. So that's t's distance. So who gets there quicker if they travel at the same speed? Well, looking at this, we know that Liz is 80 meters. Tia, we've worked out, is 86.7 meters. So who is going to get there the quickest? Liz does. And again, if you want to give a reason, that's fine. So 80 is less than 86.7, or she travels a lesser distance, will be absolutely fine. Then says, in fact, Liz walks faster than Tia. How does this affect your answer in part A? It doesn't. Oh. I just need to write it doesn't, as Liz has a shorter distance. The only way it would make a difference if Tia was walking faster, because then she'd cover a lot of distance, and it's just a case of where those excess 8.6 kilometers or meters, miles, is compensated by her change in speed. Moving on to question 20, it says ABC and ACD are triangles, and it says work out the size of angle X. So again, what we need to do first is very similar to the area question that we did actually. So looking at this length here, we need to work out what that is. So let's just call that Y, seeing as X is already taken. So from this is going to be using SOHCAHTOA trig. So if I take that triangle out, I've got Y, I've got 16, and I've got 49. So this is therefore going to be using tan. So I've got tan 49 equals Y over 16. So Y equals 16 tan 49. Now, if you want to use exact values, you can just take Y to equal this. Or if you want to write it in its decimal form, which I think a lot of students would do, we get Y equals 18.41 centimeters. And so I can label that as 18.41, or I could write it as 16 tan 49. So then from this, what I've then got to do is I've now got to use this triangle. So let's just draw that triangle out to work out what angle X is. So this is 18.41 or 16 tan 49. This angle here is 35 and this side is 20. So now I'm going to use the sine rule. So from this, I've got 16 tan. Well, let's just use the decimal. I think it's probably going to be the most popular. So here we've got 18.41 over sine X equals, and it's going to be 20 over sine 35. So then doing a bit of cross multiplying, what we end up with is 20 sine X equals 18.41 sine 35. So then sine X equals 18.41 sine 35, all divided by 20. So X equals the inverse sine of the answer. And if I type that into my calculator, I should end up with an angle of 31.9, and that's to 1 decimal place. Moving on to question 21, again another trig question. So here is a triangle, and it says work out the length of PR. So PR is this length here, which is going to call X. So as we've got three sides in an angle, it's going to be using the cosine rule. So we've got x squared equals 6 squared plus 9 squared minus 2 times 6 times 9 times cos 120. Typing that all into my calculator. Now I personally would write down your x squared value, which in this case is 171. So x equals the square root of 171, which gives me an answer of 13.1, and that's to 1 decimal place. Now if you gave your answer as a surd, that would also be allowed, because again they've given you no indication how they want the answer written, so you could basically decide what you want to round it to, but always state, if you have rounded it, what you've rounded it to. Moving on to our next trigonometry question. It says two triangular lawns are shown. Wire fencing is needed for all 5 sides, and it says wire fencing is sold in 50-meter rolls. Work out the number of rolls needed. So let's have a look at this. So first of all, what we need to do is we need to find the 3 missing sides. So let's call this X, Y, and Z. And let's look at these in that order. So to find x, let's take that triangle out and let me just give it a quick rotate. Let's call this 40. And so this is going to be 10 and x is this side here. So then using this and labeling the sides, that's going to be h, that's going to be a. So I'm using cos. So I've got cos 40 equals x over 10. So x equals 10 cos 40. So x equals, and it's going to be 76.6 meters. I'm going to add a little bit of rounding to this. So we'll round it up because we're dealing with fencing and we're going to end up buying 50. So let's just round up. So it's going to be 77 meters. The next one then is looking at y. Let's now find y. So we're just going to again use that triangle, but we're just going to rotate it. So this here is 40. Now I could use Pythagoras because I know what x is. I could then work out y using Pythagoras, but I'll stick with the theme of trig. So this is y, and this is, oh, it's actually 100, not 10. Just correct it. My answer is still correct. What I've written is not. Okay. So then from this, what we then got is using, this is going to be my opposite. That's my h. So this time I'm using sine. So sine 40 equals y over 100. So y equals 100 sine 40. And typing that into my calculator, I get y equals 64.3, which we could round up to 65 meters. Then I've then got to work out what z is. So for this, if I just write down that y is 64.3 to try and be as accurate as possible. Now for z, I now need to use, because it's not a right angle triangle, I need to use the cosine rule. So looking at this, this is 30, this is z, this is 64.3, and this is 120. So using the cosine rule, I get z squared equals 64.3 squared plus 120 squared minus 2 lots of 64.3 times 120 times cos 30. And typing that all in, I get z squared equals, and it's 5,069.985. So z equals 71.9, which will just round up to 72 meters. So looking at the fencing, so let's give it that cursor. So the total amount of fencing needed is all of those 5 sides added together. So I've got 100 plus 77 plus 65 plus 72 plus 120. Now if I add all of that up, so 100 plus 77 plus 65 plus 72 plus 120, that comes up to a total of 434 meters rounded. Now the question then says write down the fencing sold in 50 meter rolls. So I need to see how many 50 rolls do I need to make 434. So then it's going to be 434. What number is that? So let me just get that color. So then it's going to be 434 divided by 50, and typing that into my calculator, I get an answer of 8.68. So I'm going to need 9 rolls. And there is my final answer. And again, that is worth 6 marks. So you can see where that, although it took me quite long to do, I'm definitely going to get the marks awarded for it. Moving on to question 23. So it says use the cosine rule to work out the size of angle x. So from this, I'm going to be using cos A equals b squared plus c squared minus 2. No, I'm not. Minus a squared. Now again, the good thing for you to remember is that these are all on the formula sheet for your 2022 exam, and that's going to be 2BC. So then substituting numbers in, this is a, that's little a, this is going to be b, and that's going to be c. So I've got cos a equals 11 squared plus 12 squared minus 15 squared. all divided by 2 times 11 times 12. Now that fraction is going to equal a potentially a negative number, which I don't think it does actually, so it should be okay. So here we get a equals the inverse cos of 5 over 33, which is basically what this fraction simplifies to, in which then I get a, which in other words we'll call x, is equal to 81.3 degrees. Moving on to B, it says use the sine rule to work out BC. So again, BC is this side here. So then labeling this up, we get A, B, little b. And sine rule, one variation is this. And again, this is given to you on the formula sheet. So substituting numbers in, we get x over sine 35 equals 8 over sine 74. Cross multiply. Then take the sine 74 over to the other side, in which I get an answer of 4.77 centimeters, and that's to 2 decimal place. Moving on to question 24, which looks at ratios and vectors. So it says PQR is a straight line. P to Q to R is in the ratio of 3 to 1. PQ is A. Circle the vector of R to Q. So first of all, let's have a look at this ratio. So the amount that we want to share, so the total equals A, and that equals 4 parts. So then one part, so if A equals 4 parts, then A over 4, or a quarter, let's get rid of that. So A over 4, or a quarter A, which I'm going to use, equals 1 part. Now, this in that direction is 3 parts, and this in that direction is 1 part. So then if 1 part, so going in this direction, it's a quarter A. So then going in the opposite direction, it's going to be minus a quarter A. So the one that we should highlight is the last option. Then moving on to question 25, we now move on to vector arithmetic. So here we've got 4C plus 3D. So we want to do 4 lots of C minus or plus 3 lots of D. So 4 times 4 is 16, 4 times 9 is 36, plus 3 times 2, which is 6, 3 times minus 5 is minus 15, and then we just add the top 2 numbers together. So 16 plus 6 is 22, and 36 take away 15 is 21. Moving on to question 26, again we're working out A minus 3B. So we've got A, which is minus 3, 2, let me just get rid of that. People attempt at writing an A. Minus 3 lots of 1 minus 5. So that then becomes minus 3, 2. That stays the same. Minus 3 times 1, which is 3. 3 times minus 5, which is minus 15. So minus 3 is 6. 2 minus 15 is 17. So I'm looking for 6, 17. And that should be a minus there. So it's our first option. Moving on to question 27, we want to work out 3A plus B. So we've got 3 lots of 2, 7, plus 5 minus 2. So 3 times 2 is 6, 3 times 7 is 21, plus 5 minus 2. So that then becomes 11 and 19. Then moving on to question 28, it says to work out 3F minus 2G. So 3 lots of 4, 5, minus 2 lots of 5 minus 2. So that then becomes 12 and 15, minus 10 and minus 4. So then that then becomes 12 minus 10, which is 2, and 15 minus 4 is 19. It's 219. And then moving on to question 29, it says C is the midpoint of AB. And it says Q to A is 2A, O to A is 2A, O to B is 6B. Work out O to C in terms of A and B. Simplify your answer as possible. So let's first of all work out what A to B is. So this little red line here. Now that is going against, so that's going to be A to O plus O to B. Now A to O is minus 2A and O to B is 6B. So then A to B equals minus 2A plus 6B. Now, because C is a midpoint, then what that tells us is that this little bit here is going to be half of this. So that's going to be minus A plus 3B. And this length here is also going to be minus A plus 3B. Now, to go to O to C, the route I'm going to go is I'm going to go O to A plus A to C. Now O to A is 2A plus A to C, which is minus A plus 3B because going with the arrow. So then simplifying this, I get A plus 3B, and there is my final answer.